Right, so back to this, number 11 then. So cumulative frequency question, and first question is, what's the modal class? So this is the most popular grouping. So if you look down the numbers there, 36 is the most popular because it's the highest frequency, so it's 100 less than 200. Okay. Next we've got to fill in this cumulative frequency table, and that's just simply a running total of these numbers. So we start with 10, then we add 36 to 10, so it becomes 46, then we add 34 to 46, 80, then 100, 115, 120. This number should be all of them added up. In this question they actually tell you 120 there. Okay, on the next side we're going to plot the cumulative frequency graph. Remember, we've got to plot these, the upper boundaries, not the midpoint, as so many students often do, against the cumulative frequency. So, first one's 100, 10's there, then 246 is there, 380, 400, 100, 500, 115, so that's 110, 115 is about there, and then 120. Now you're supposed to draw this nice smooth curve with a pencil normally, but I'm doing it in a pen so you can see what I'm doing. Okay, so there's my graph. Use your graph to find an estimate of the interquartile range, where the interquartile range, IQR for short, equals the upper quartile, take away the lower quartile. Okay, so it's 120, so a quarter of 120 is 30, so if we go along there and then read down, okay, so lower quartile, mine looks like 160, upper quartile, 3 quarters 120 is 90, so if we go along 90, we come to there, and on mine it looks about 340, 350, so I'll go 340, so 340. Now the examiners, if you draw these lines on a ruler, they like that, okay, because they see what you've done. So 340 take away 160 equals 180. Okay, so that's the interquartile range. Then the last question on this one, use your graph to find an estimate of the number of families spent more than £450 on holiday. So 450 is here. Okay, so we're going to go up to there, and you can see going along there. Now that's distance there, and more than, so it's above this, so it's 12 people. So 120 minus 108 equals 12. Okay, nice easy question, 8 marks, great. Okay, next one, circle theorem. Work out size of angle ADC, so they want this angle. Okay, now if I can work out that angle, then it's quite a straightforward circle theorem that we should remember, because this one in the centre is twice as big as the one on the circumference. So if I got that angle, I half it to get that one. Now what we got here, so tangents, that means that's 90. Okay, so I can work that angle out because it's four-sided shape. So I want to show your workings clearly. So I'm going to say angle OCB equals angle A, no, that's wrong, BAO equals 90 degrees. Therefore angle AOC equals, so those two are 90, so that's 180, so this plus this must be 180, so 180 minus 74 equals 106, and therefore angle ADC equals half of 106, which equals 53 degrees. Great. Next one. Straight line graph. So we have to find a perpendicular line to this one that passes through this point. And then once we've got that equation, we can find the coordinates of a point which cross the x-axis. Remember, on the x-axis y equals 0. Okay, so first of all, let's find the perpendicular equation. So the gradient of this one here is -2. So therefore, remember, m1 times m2 equals -1 if they're perpendicular. So therefore, our perpendicular gradient, we'll call it m2, is -1 divided by -2, so it's just half. Okay, so stick it into our standard y equals mx plus c. Now m is a half. Using this coordinate here, y is 7, x is 4. So therefore c, if this is 2, c must be 5. Okay, so my equation is y equals half x plus 5. Now it crosses the x-axis, so it crosses the x-axis here. And as I said before, when y equals 0, so when y equals 0, half x plus 10, plus 5, rearrange that, so I got half x equals -5, so x equals -10. Okay, so it's -10 is the x, and obviously the y coordinate's 0. Nice little indices problem. Right, 128 is 2 to the 7, so 128 is 2 to the 7. Okay, and you're told that equals 2x times 2x. Now 4 is 2 squared, so you can rewrite that as 2 to 7 equals 2 squared, so that's 2 square, so that's 4x times 2x. So now all these bases are the same, and the indices rules is that plus that must equal that, so therefore 7 equals 4x plus x, which is 5x. So therefore x equals 7 divided by 5, which is 1.4. You could leave it as a fraction, normally I would do as well. Venn diagram. Okay, so look, this is a different one. This is n, so this is the number of members. It tells you to, these each represent the number of elements within the set. So for instance, set A has 10 members, 7 plus 3. Okay, so A or B, so simply that plus that plus that plus that. So 7 plus 3 plus 8 plus 1 equals 19. Not A and C. So not A is everything outside A, and C where it overlaps. This means where it overlaps, intersection. So this, where not A and C overlap, is just C. So that's 1 plus 4 equals 5. And this is the union of not A, so not A and not B. So not A is what I'm shading here. Oh, you can't see it, so I'll move it. Not A and not B. So it's that plus that plus that plus that plus that. So the only thing it's not is this 3. So 7 plus 8 plus 1 plus 4 plus 9 equals 29. Turn over probability question. There are 8 counters in a bag. My mum takes 3 counters she had. Work out the probability that a total is an odd number. Okay, so we got odd and even numbers, obviously. Now the only way of getting an odd number is either having 3 odds or 1 odd. Oh no, yeah, 2 evens. Okay, so what I'm going to do is do a tree diagram. Okay, so that's represent the first counter she takes out of the bag. This is then going to be the second counter, and then this is the third counter. Problem with drawing these is with 3 is you can run out of space. Okay, so odd, even, odd, even, odd, even, odd, even, odd, even, odd, even, odd, even. Now using the tree diagram just show all the combinations. So probability she takes an odd one first of all is 1, 2, so 5 out of 8. So that must be 3 out of 8. Now if she's taken an odd one already, this now becomes 4 out of 7. Similarly, this is 3 out of 6. This must be 3 out of 7. This must be 3 out of 6. Coming down here. So take an even. So this one's 5 out of 7. This is 2 out of 7. 5 out of 6. 1 out of 6. 4 out of 6. 2 out of 6. That's the same. Okay. Now, as I said, odd, 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 so that'll give you an odd. So that we want this one. Odd, odd, even, that's even, so we don't want that one. So odd, even, odd, that's even, so we don't want that one. Odd, even, even, we want this one. So that'll give you an odd one. Even, odd, odd, that's even. Even, this is odd. And this one's odd. So I just need to calculate these 4 cases and then simply add them together. Right, so I've got 5 times 4, 20 times 3, 60 over 8 times 7 times 6. Well, obviously I'm going to use a calculator for that. And that is 336. This one now, so this 5 times 3, so that's 30 over 336. 30 over 336 and 30 over 3. Can't write. Okay. So therefore, probability odd equals 60 plus 30 plus 30 plus 30 all over 336 equals, and again let your calculator do the work here, so it's 150 over 336, and your calculator tells you it's 25 over 56. Okay. Okay, next one, recurrent decimal problem, need to show, and this, so standard way of doing this is let x equal 0.436336. Now, I need to get 2 multiples of x which both end in 0.36, 0.36, 0.36. So when I subtract them, that stream of decimals disappears. So if I go 10x, that obviously equals 4.363636. Now if I did 100x, that wouldn't be any good because it would be 43.6363, and I want 0.36, 0.36. So I'm going to have to do 1000. X is 436.363636. Now, if I subtract these two, so I do 1000x, take away 10x, that's 990x equals 436, take away 4 is 432, and you notice this all cancels, which is what I wanted. So x equals 432 divided by 990 equals 24 over 55. Cool. Right, what we got here? Right, so it's the third problem. We've got to simplify it into that form. Okay, you could type this into your calculator, but what the examiners have done recently is they've made the answer, so you've got to understand a bit more about thirds rather than just write down what you get on your calculator. Anyway, I'll do it from first principles without a calculator. So, root 20 is 4 times 5, so root 20 can be written as 2 root 5. 80 is 16 times 5, so that's 4 root 5 all over root 3. Okay, now I'm going to get rid of this root 3, obviously. This equals 6 root 5 over root 3. Now we don't leave root 3's on the bottom, so I'm going to multiply the top of the bottom of the fraction by root 3. Okay, so this becomes root 3 times root 3 is 3. And then I've got 5 times 3, so 6 root 15. 6 cancels down to 2 root 50. Now notice they don't want this now, so they don't want this number out, so you need to take that 2 back into the square root. So if you square it, it becomes 4 times 15, okay, which is 60. That's the answer, so A is 60. Okay, so nice quadratic simultaneous equation. Okay, so there's going to be 2 pairs of answers here for x and y. See from this equation, we're going to need to make a substitution for x squared because I've got x here. So x squared equals 4y squared minus 12y plus 9. Remember, you just write it out twice and expand double brackets the normal way. Now I'm substituting for 2x, so I'll just double this here. Okay, now I'm going to substitute that for this, okay, and the only thing is I've got another 3y squared. 3y squared plus 8y squared is 11y squared minus 24y plus 4 equals 0. Actually, they've been good to us here because this is a prime number. If it factorises, the only way it's going to factorise is if you have 11y and y in the 2 brackets. Now, to get 4, you could do 4 times 1 or 2 times 2, so try the 2 in your head. They both have to be negative signs because that's a negative, and negative make a plus, right, so 11 times, right, I can see it's 2, because 11 times 2 is 22, and then another 2 give us that 24, so there's the solution. So therefore one of the solutions is y equals 2, and the other solution is y equals 2 divided by 11. Remember, this is 11y minus 2 equals 0, so it rearranges to that. Now we need to go back and calculate what the corresponding x is. So here, using this equation, so when y is 2, 2 times 2 is 4, take away 3 is 1, so x equals 1, so that's one pair of answers. Here, not so easy. 2 times 2 over 11 is 4 over 11, minus 3 wholes, so that's minus 33 over 11. So I've got, let's do it, so 4 over 11, take away 33 over 11 equals 29 over 11, minus, so the one that goes with that is minus 29 over 11, okay. So you could write them as 1, 2, that's one solution, and the other solution is minus 29 over 11, 2 over 11. Okay. Oh, great, these are easy. So work out the upper bound of A. Okay, so A equals P minus Q over T. Now, for this to be the upper, This needs to be the biggest number possible, and then this needs to be the lowest number possible, because when you subtract a small number you'll leave the biggest number, and when you divide into it you want that's the lower one. Okay, right, so P upper, this is two significant figures, so the maximum that could have possibly been was 8.45. The lowest that one could be, remember we want lower there, is 6.25, and then this one, the lowest one, so this is two significant, but look, it's got decimal places, so this is 0.265. Okay, so we stick those numbers into that simple equation, and you got 8.45 minus 6.25 divided by 0.265. Remember, if you type all this into calculator, you need to put that in brackets, otherwise you'll get some strange answer. So 8.3. Nice easy one, that one, for question 19. Solve the inequality. Now looking at this, it doesn't look like it factorizes, so I'm going to use the quadratic formula. So x equals minus b, so a is 4, b is minus 5, c is minus 6. Okay, so sticking that into the quadratic formula, alright, I can move it down here, equals minus 5, so that's 5, plus or minus the square root of minus 5 squared is 25, minus 4 times 4 times minus 6, so that is plus 96, and that's all over 2 times a is 8. Remember this formula, and you just get it from the front of the paper. Okay, so you get x equals 5 plus or minus, this is 122, square root of that is 11 over 8. Okay, so your two answers are 5 plus 11, so 16 over 8, which is 2. And the other answer is 5 minus 11, so that's minus 6 over 8, and minus 3/4. Okay, now, because this is an inequality, you need to consider the shape of the quadratic. So this is a positive, I'm pointing here, because this is a positive x squared, it's a U shape. Okay, it's U shape, and we're looking for where it's bigger than 0. So here are the roots, so we've got the roots here, one's at 2 and the other one's at minus 3/4. Now where it's bigger than 0, where this function is bigger than 0, where y is bigger than 0, is beyond here, beyond 2, and less than minus 3/4. Okay, in between, y goes less than 0, this bit here is less than 0, so therefore you write the inequality, the final answer is going to be when x is greater than 2 and x is less than minus 3/4, because that's where it's bigger than 0. Okay, so question 21 is a graph transformation problem. So this is the function, and what we're going to do is we're going to apply this translation to it. So we're doubling the function now. Remember, when you double this, you're doubling everything in the y direction. So this point here, the x is the same, but that doubles to 6. This is minus 1, so it doubles to minus 2, and that one's same thing. And then with a ruler, I can't seem to find one in a moment, but you draw this in like that. Okay, that's quite easy. Turn it over then. So again, we got the function, and we got a translation. Right, so we're going to perform negative to all the x values. So what that means is it is a reflection in the y-axis. Okay, so this point will go there, this point reflects, it goes there, this point reflects across and goes there. Again, draw in with a ruler and a pencil. There we are, that one's